How you doing, guys? Today we're looking at chapter 54, alternator construction and different types of ways that alternator operates. This chapter is only exclusively for the alternator. There's a couple of worksheets that we would do with this normally. Charging system voltage. I think I did one demo for you guys on my truck regarding that, showing you how to use a multimeter for the charging system part on that. So basically there's a couple of things we're looking at what an alternator does. It basically rotates the engine and helps us with belt driven rotation from the crankshaft, and that allows us to help increase and turn alternating current to DC current, direct current. An alternator produces alternating current. So within components within the alternator, typically from the diode side of it, they're going to convert that AC into DC directly, to go back to the battery to help us recharge that battery, because the battery cannot be charged or recharged with alternating current. It only accepts direct current. So we're going to be looking at how that works in a little bit here. The alternator basically has two housings, front end housing or drive housing, and a slip ring end housing. Normally 3 to 4 bolts, but typically 3 that hold it together in place. And so we're looking at basically the pulley part of it is where it's belt driven. Normally you have bearings, and some of them have clutches within the bearing assembly. More expensive alternators, those are help to reduce vibration, noise, especially during low idling condition speeds. There are an overrunning alternator pulley that takes place there, as well as the overrunning alternator dampener, which is another aspect of a pulley assembly within a clutch and where the belt drives around. So it helps reduce the amount of noise that takes place, especially at low RPM speeds. We've got a rotor that on page, if you look at it on page 580 there, you're going to show a rotor that rotates with the engine RPMs. We have slip rings that hooks up to it that's been driven through field current. You typically have a positive and negative slip rings that coincide with there, and we get voltage applied to there from the key on engine off. So with the key on engine on, we should have voltage going to the slip rings. That's going to help produce current flow when we start the vehicle up, and that rotor turns. It rotates freely into a stationary section called a stator. A stator is basically heavy turns of cold wire that are in place, and typically we have within that 3 different terminals that will come out and hook up with our diodes. Okay, for each one you'll have a positive and negative diodes per each stator, so typically you'll have 6 diodes that we have on our alternator that help with the field current and changing that alternating current to direct current going back to our battery. The diodes are a one-way electrical check valve, so it only allows the field current to go in one direction and not the other. There's another one that we're going to talk about in a little while with a voltage regulator that will have a Zener diode in it, and we'll get into that in a little bit. But typically the diodes are one-way electrical check valves. On page 581 they show you a rectifier bridge, and this one it has 3 different diodes inside of it, and this is designed especially for a lot of alternators. It kind of looks like a radiator at the top and lower part of it. That's basically a heat sink. Okay, that's to help cool out the diodes when the vehicle is running, with the ROM air coming through the alternator, which are air cooled, by the way. There's a couple later on that they tried out at the past that were coolant cooled, so they had a coolant hose that came through it to help remove the excessive heat from the alternator, and it took it back to the radiator through another small coolant tube. But typically we don't see too many of those right now. They did come out with them just to kind of show you what it looks like there. We look at the field current, which is producing current flow through it. There's a couple of types of field current designs within the diodes that we generate within the stator. There's a Y type and there's a delta type. The Y type, or the earlier type of alternators, that have a specific connection where it changes alternating current at a very slow rate. Especially, it produces a good amount of current flow, but the delta type happens to be the most efficient one, especially with high current type alternators. And there's a picture of that on 583 there at the top there. It shows you the Y type stator and a delta type stator. Delta type stators, like I said, they produce a little bit more, 73% more current flow than a Y type alternator, which is a little bit more expensive, by the way. So as we look at the proper amperage, we go anywhere between, we used to have 50 amps, now we're going to 180 amps, it's 160 amp alternators at high output. So, and of course the price range anywhere is between, $80 to like $265, $300 for an alternator now. It depends on the manufacturer, okay? But the more expensive alternators have a delta type of stator winding, and the more flux lines that take place inside a stator, the more current output is available, especially with all of our electronics and all our modules and computers that we have on today's vehicles. We have to have an alternator that can put out the sufficient amount of current and have the longevity of establishing a high current flow to all our modules on our vehicles. Typically, like I said, BMWs, man, they have anywhere between 40 to 90 modules. So the alternator on that one has got to be efficient enough to keep the vehicle's electrical system load and demand at a higher peak. Otherwise, we can have some auto quality or drivability performance issues, and you can't have a check engine light or a service agency light come on, indicating you may have a faulty alternator that can cause some severe concerns. As well as we know, if an alternator's diode stays shorted, it can also rob the battery of current. So kind of keep that in mind. Voltage regulation, typically we have a voltage regulator that's supposed to help sustain voltage between 13.6 to 14.2, what we talked about earlier in the chapters. On some late model vehicles, it can actually go up to 15.5, 14.2 to 15.5. So we have to consult our vehicles manufacturer specifications to find out what range our voltage regulator should be. And our voltage regulator, again, those have diodes in it, and this is the one where we have a Zener diode. And a Zener diode, what that basically does, it helps conduct current to our transistors, which are the diodes, because the diodes are like an on and off switch. And as it reaches its peak height, it generates more current flow. It helps generate more current flow. So that's what Zener diodes do for us there. As the battery starts to sulfate and gets weak over a period of time, like we mentioned, 3 to 5 years, or 3 to 7 years for a battery life, 2 years for a factory battery life. But as that battery plates start to sulfate, now our alternator's got to do a better job of generating higher current field to our battery to help rejuvenate our battery. The thing that we see a lot on today's vehicles is we have computer-controlled alternators that help out with the electrical loads, that help out with idle qualities. You may see, for instance, if you're driving and you come to an idle, that all of a sudden the RPMs will go up on you just because. Well, the computer probably is generating a signal to the generator or alternator to help increase the current flow, which will increase the auto quality momentarily. It's not a drivability concern. It is something that the computer hasn't embedded in to do, and that's the way it functions. So on page 586, there's some conditions that could be met right here on computer-controlled charging system. There's a fault in the system, you will get a code for it. So main thing to do is to, once you get that code, is to, of course, write it on the work order, and then look at the procedures on trying to diagnose any charging system fault codes that could be present. So we've got the lighting systems that we're going to be getting into next time on Wednesday. I'll try and see if I can get a couple of demos that I can try and fit in there for you guys regarding that. But I want you guys to help each other out. Be safe and stay at home, and we'll get through this. You guys have a good day.